Okay, now in example 2, we're going to be estimating the slope of a tangent line from experimental data. The flash unit on a camera operates by storing charge on a capacitor and releasing it suddenly when the flash is set off. The data in the table describe the charge Q remaining on the capacitor, measured in microcoulombs at time t, measured in seconds after the flash goes off. Now we're going to use the data here that's given in the table to draw the graph of this function at the point where t is equal to 0.04. Note that the slope of the tangent line represents the electric current flowing from the capacitor to the flash bulb, which is measured in microamperes. Okay, now if you notice here, again, we're investigating at when the value of t is equal to 0.04, which is right here. Okay, and so now it creates this point on our graph here, and we can see that this point then has an output of, over here, 67.03. Okay, so now, since that is the point that we're going to be using, so the point that we're selecting here is when x is 0.04 and the output is 67.03. Now again, these are data values that's been given to us. Okay, so if we want to pick some point on this particular graph, okay, we can then find the slope. But we don't have an equation in this example. We have other points in the table that's given. So what we can do is we can pick another point here at the beginning. So that's this 0, 100. So we can use that point to then determine what is the slope of that. Okay, so if this is P, we can call this point R. And what we want to do is we want to be able to find, okay, what is the slope of that line? So we're going to start out here and write down the slope of PR. Okay, we have our y1, which is 100, minus y2, which is 67.03. And then we're going to divide that by x2 minus x1. And that gives us a slope of negative 874.25. Okay, so you can see here that that gives us the slope when we're using the point 0.00, 100.00. Okay. Now we can continue to do that to find the slopes like we did in the previous example by using these other points, okay, to determine what is the slopes for each one. Okay, but what we want to do is that the table at the left shows the results of those similar calculations for the slopes of the other secant lines. From this table, we would expect the slope of the tangent line at t is equal to 0.04 to be somewhere in between negative 742 and negative 607.50. So if you take a look here, okay, look at the x values. Well, the x values here is at 0.02 and this is 0.06. So that means that 0.04 is in between those two values, which means that the slope would have to be in between negative 742 and negative 607.50. So what that means is that we can actually find the averages of those two slopes of those secant lines. So we're going to find the average slopes of the secant lines when x is equal to 0.02 and x is 0.06, because again we note that 0.04 is in between those two values. So if we need to take the average of that, the average, okay, is basically saying, well, we're going to take the slope, negative 742, and then we're going to add the slope of 0.06, and that was negative 607.50, and then we're going to divide that by 2, or we can take half of that. And so then we're going to get the slope here to be negative 674.75, which is approximately negative 675. So what we've done is we determined that we estimated the slope of the tangent line to be negative 675. Okay. Now, another method, okay, that we can do is by drawing an approximation to the tangent line at P and measure the sides of the triangle ABC. So here we create a triangle, right? Okay, and so remember that the tangent, okay, is equal to the value of what? Y over X. Okay, so we're going to look at the side AB and then the side BC. Okay, so again, this represents our Y, right? When we're talking about the definition of tangent, okay, over X. So what do we know? Well, we know that since this is going down, the slope is going to have to be negative. So we know it's going to be negative, okay, regardless. Now, we also know that here, okay, we'd have to make sure that this distance is positive and this distance is positive, because regardless, it's going to be a negative slope. So we need to take the absolute value of whatever the distance is of AB and then divide that by the distance of BC. Okay? Now, how do we determine that? Well, again, we know that it's going to be negative. Okay, and what is the distance from A to B? Well, in this case, if we take a look at this triangle, okay, if we look at that point and determine what is the value here, Well, it would be at 80.4. It's one way of being able to determine that. So looking at that point where that triangle is, you got 80.4. Okay, and then you're going to subtract what the distance here is, which would be 53.6. And then we're going to then find the distance between these two. And so the distance would be 0.06 minus 0.02. And so then we get approximately negative 670. Okay, now again, we are estimating the slope of this tangent line, so it should be pretty close to negative 675. So yeah, it's off about 5 units there, but they are pretty close. Okay, so the physical meaning of the answer in this example is that the electric current that's flowing from the capacitor to the flash bulb after 0.04 seconds is about negative 670 microamperes.